Good day everyone. Today we are going to introduce to you our software tool that was named Vercingetorix, which was designed to address class imbalances within datasets by the utilization of CNN, or convolutional neural networks that was combining with gradient boosting classifiers. Our first task is to train a model on a dataset, specifically a Filipino Sign Language dataset. In this process, we are going to implement the ResNet50 model and gradient boosting technique classifier to balance the classes. The key challenge was to handle the class imbalances ratio, which was around 36% across all the number of quantity of various images. To tackle this, we employed techniques like the weighted cross entropy to account for the class distribution, where the model was trained for 50 epochs using ResNet50 as the base model. During the training, we monitored metrics like the accuracy, the loss function, and the class-specific performances across epochs. After training, we integrated the gradient boosting to enhance the model's accuracy. Gradient boosting uses multiple decision trees, of course, which is meant to analyze the weights and features of the initial CNN model, which was the base model, to refine predictions further, each in according to its specific trees that was improved using its example task. At the end of this training phase, we generated a matrix of predictions, which we'll examine shortly. This matrix gives us the insights into how well the model has learned to classify different signs and to address the class imbalance effectively. Now let's move on the evaluation phase. The model called PATS was trained using the FSL dataset and will be evaluated on the corresponding FSL test set. We have an Evaluate FSL Model button in the software interface, where we are going to load the model in the H5 format, the format used for storing trained Keras models. After loading the model, we are going to proceed with the evaluation process, which will include calculating the key performances metrics, accuracy, precision, recall, iPhone score, and a confusion matrix. One important aspect of our process is the integration of SMOTE, or the synthetic minority oversampling, which was applied to mitigate the class imbalances further on other forms of dataset. SMOTE will of course generate synthetic samples for the underrepresented classes. Okay. After running the evaluation, the results were output in the terminal. The confusion matrix provides us with a clear visual representation of the model's prediction versus the actual values. As we look deeper into the results, the diagonal of the confusion matrix, which will reflect the correct predictions, showed strong results, indicating a good model performance. Gradient boosting in particular contributed significantly to improve the classification accuracy across all classes, especially for the underrepresented ones. The model's performance improved as the prominence of the diagonal increased, showing the model's ability to generalize well despite the initial class imbalances. Moreover, our system is highly adaptable and can be applied to other datasets. For instance, we tested it on a fruit dataset, demonstrating the versatility of our approach. You can see in the screen that we have apples, bananas, oranges that are predicted carefully by the model and accurately with high precision. Okay. We also tested this on a cancer dataset on our other approaches, and it has also yielded good results. Since the primary focus of our project is Filipino Sign Language, we applied the model in real time to recognize various sign gestures. Using the live view feature of our software, we demonstrated signs like today, thank you, and morning. The model was able to correctly identify each gesture with high accuracy, further showcasing its practical application in real-world scenario. This live testing is crucial for demonstrating the robustness of the model in dynamic environments, where real-time recognition and quick response times are essential. These examples represent just a fraction of what the model is capable of doing. It can be trained and adapted to various datasets and use cases, making it a powerful tool for different applications, from sign languages to other forms of image and gesture classification. And that concludes our demonstration of the software. We hope this presentation has given you a clear understanding of how CNN gradient boosting has been applied to various datasets in fixing the class imbalances of various complex entities. Thank you for your time, and we're happy to take any questions that you may have.